Greetings. It's Motzei Chag Pesach, Motzei Shvisha Pesach, and I'm going an overview of my circuit, which is a fork from the mainline circuit of Ambovent. Okay. My circuit is 100% redundant as its design outlook. Okay, we're going to start go through the circuit from very quickly. Okay, we'll start off with the power supply. The power supply, the circuit is a linear power supply. The final version will have switching, but at this point in time it has a linear power supply. The linear power supply goes down in two stages, from 12 volt to 5 or 6 volts, and from 6 volts to 3 volts. You don't want to put 12 volts into the 3.3 volt regulator directly. Not a good idea. I'm not going to go into details. Should you not want to use two power supplies, you can jumper one power supply. These are the jumpers. We have auxiliary 3 and 3 volt main. The ESP main runs off the 3 volt. The 3 volt main power supply, and its USB to UART also runs off the 3 volt main. The backup runs off the auxiliary power supply 3.3. If you only use one ESP and one power supply, the auxiliary falls away, but the option is there to use an auxiliary. This jumper JP2 allows you to press the reset on either one of the auxiliary or main, will cause a reset on both. The final version will have some type of watchdog, but I don't want to get into that at this point in time. What is a watchdog? How is a watchdog? Okay, moving up. Starting in our top left corner, we have the test switch. The test switch has changed from SPDT to a DPDT. Single pole to a dual pole. When you press a switch, you are switching SW1 to ground, and you're also switching SW auxiliary to ground. So we have, once again, redundancy. The name of the game is redundancy. I've replaced the switch. This is the switch I had on the mainline board. This is the switch I put on my board. It is a two-part solution instead of a one-part solution, and one doesn't need to drill the hole bigger. If they want me to change it, I can change it on the one I did for them. Okay. Going back in, going back to the ESP, one can see that I'm running very low on GPIOs. Running very low on GPIOs, and more than likely the LEDs will be moved to the JTAG connector. It means I don't need to debug LEDs. I just don't have the LEDs around with a debug, or I will use NeoPixels, which is in one line. Okay, I'll explain later why NeoPixels becomes a better solution. Going up. Okay. I explained the switch. The alarm reset switch also becomes a two switch solution, one for the main, one for the auxiliary. LEDs, I will deal with the LEDs in more detail when I get to the PCB. Okay. I have three potentiometers which give at this point in time the user interface. The user interface is defined by the three potentiometers. I'm thinking of changing it, but I will explain when I get to the PCB. One can see CT1 and CT1 auxiliary, CT2, CT2 auxiliary, CT3, CT3 auxiliary. Motor feedback auxiliary. The pause run button. The pause run button is, I've left it as a single switch. I haven't doubled it up to a dual pole switch because I need a very small switch. I don't want to go for a dual pole switch in a very small form factor. The display, we'll see on the PCB how this display has changed. Okay. To the PCB. This is the PCB. First thing one notices is the display changing from a 2-line character display to a 3.2-inch TFT display with a resistive touch. This has forced me to go to use more GPIOs than the original design. This is the reason I'm running out of GPIOs. Okay. Top corner. Top corner, the test switch one can see is now 6 pins, not 4. Test switch, you're switching 2 sets of contacts, alarm the same. Okay. Looking at the back of the board. The back of the board, you have 2 separate 12-volt inputs, 2 USB connectors, one for main, one for auxiliary. Power supply, 12-volt, intermediary voltage, 3.3 volts. Two ESPs, You obviously don't have to install 2, but the option is to allow for 2. GPIO JTAG headers, reset and flash headers. Okay. At this point in time, I foresee putting us another I2C link in for auxiliary I2C going to a secondary sensor, which would allow along the lines of redundancy. Redundancy and having two bags, 2 motors, 2 position sensors, everything doubled up. Okay. Okay. As I've changed to an ESP from the Arduino, I have Wi-Fi and have a BLE connection to the device. So if you have Wi-Fi and you have BLE, you want to have a way of remotely changing the parameters on the device, as well as having a touch interface. So if you're doing that, the last thing you want to do is to use potentiometers which output analog voltage to set your parameters. So when I said that I was going to talk about LEDs and changing the LEDs to NeoPixels, these potentiometers conceivably could be changed to NeoPixels. Conceivably changing the potentiometers to NeoPixels, and in the top left, on the top left, I'll have a rotary encoder. Up, down, choosing and cycling through what parameter you want to do. You press the button, the NeoPixel for PWM will light up. You can set the BVM. You want to change the rate, press it again, it'll cycle through rate. And on the screen, you will have the parameters. You will not have the parameters will not be set up via some analog voltage put out by a potentiometer. The reason for this is that if you want to have remote changing of parameters, one does not want to set directly to an analog voltage. Okay. That is a future idea. At the moment now, I'm using analog voltages. Instead of trying to use the most generic potentiometer which a person could pull out of an old FM radio, which was the idea of using those old school potentiometers I put in the main line. I put in the main line specifically old school type potentiometers in case someone is going to harvest them from scrap. It was a known move and something I did. As I'm designing everything now from scratch, and I'm designing the whole unit from scratch, I'm allowing myself not to use old school potentiometers pulled out of some FM radio. Okay, so this is an ALP potentiometer. Once again, one can see that when you turn the knob here, you are changing the resistance on both sets of potentiometers. You've got two sets. You've got six pins for the potentiometers. So once again, here we have backup. Here we have on the potentiometers we have auxiliary. Okay, I'm going to go through where we have auxiliary. Test is 2 switches. This, because of its small form factor, I've used one switch, and I haven't doubled up to a dual pole, dual throw. And I'll get to another reason why I also haven't done it, because there's another point which is why I also left that switch as it is. Alarm is switching both. Reset alarm, reset both, resets both. Test tests both. These two are dual. This is dual. I have one screen connected to the main. Okay. If I move back to start hold. If I move back to start hold, I may remove the start hold function, and I will explain why. Because as one can see, is I have created a circuit which is as far as possibly made 100% redundant. It is as close as damn it to 100% redundant. However, let's assume we are in a country where they would want to run the system not as one ventilator with backup, auxiliary backup. They want to run this as 2 ventilators on one board. So each patient will have a bag going to him. Each patient will have a bag going, would have a amber bag, and you'd only have one box dealing with 2 people, doing with 2 people. With the second amber bag would be used as a second patient and not as a backup for when the first one fails. Which would mean I would need to do this not on a hard switch like this, because I'd want to, I don't want to use a pause hold switch and then I suddenly stop both ventilators, and I only intended on stopping one. So this is a stop hold might become only a virtual switch, a touch switch. And I might put a LED there. I might just leave it out altogether. Okay. Depending on that, I'm allowing the system to run either as one ventilator with backup or two individual ventilators. Okay, this is a relatively major project, and I'm one person. I'm not a team. Okay, as more than likely I'm leaving Israel to India. I've been out of work for 18 months. My skills are, I don't lie about what I've done. I don't upgrade what I've done. What I've done, how I've done, where I've worked over the last 30 years is all clear in my resume. I don't lie about my level of education. I don't lie about my experience. I don't exactly lie and say that I've done 3.2 gigahertz DDR4 PCB design. I don't lie about it. And within Israel, at my age, you are used goods. And after 18 months of looking for work, I've come to the realization you're wasting your time. So the idea would be to move to India and go into semi-retirement, and projects which are worthwhile for people like this will get done. Okay. 2 days ago, I made a phone call to the person who is leading Ambovent. The person who's in charge with Ambovent is a person named David, and the person who's running the less technical side of it, like funding and support, is his father. And I'd spoken to Giora beforehand, and because the first time I saw this project, it was an absolute facepalm. Who did this? Was it a 2-year-old or a 3-year-old who did the PCB design? Was it a game? Did you give the design of this PCB to someone who didn't know how to use the software? Person who didn't know how to use the software. Everything that I said, and shall we say, I wrote brought up technical issues with Giora, and it didn't go down that well. Okay, I feel obligated to say also that I knew that Giora had approached some professional or so-called professional to redesign the board, and that he was using a 4-layer PCB. And above that, the person who was designing the 4-layer PCB was not prepared to share his CAD files or his Gerber files. You can buy the board from him. He will sell the board online. But he was not giving away his time. Okay. I am a person who supports open source and open source hardware specifically. And this, to me, was unacceptable, and one of the major reasons why I created the board and said, take it. And I know that my board will be 10 times better than the idiot on his 4-layer board. 4-layer board I did not. I called once again. I called the person who is running the project, and he was busy, and he promised to call me back with I was waiting for 7 o'clock to have a Sichat Veda, a conference call on how I can contribute to the project. The call never arrived. The call never arrived. So, if the call never arrived, then I am not obligated to the project. I'd offered my work, I'd offered my expertise. If they thought it wasn't needed, if they thought I was too critical, I was too technical, I was making something which would be somewhat too useful, possibly. But the moment they didn't call me back, I allowed myself to go down my own route and to create it the way I see fit. And the circuit that you see here with 100% redundancy is the way I see fit. This is the way I see fit to do the circuit. my door is open, they have my phone number, and they can contact me. Until such time, I'm working on my own fork.